Will be introducing you to finding probability using Venn diagrams. You probably look at this and go, oh, I've seen that before. You did start looking at Venn diagrams in elementary. And then probably about sixth grade or so, and now we're going to introduce how to use them to find probability. So Venn diagrams are an illustration, so a picture, that uses circles to show the commonalities and differences between things or groups of things. So if we have a group of events, we're going to call this event A and event B, then what you notice is that they have something in common. What they have in common is where they intersect. So we would call this the intersection of a Venn diagram. Other things to understand is that within circle A, but not including the intersection, this would be A only. A only, and over here would be B only. Here in the middle would be A and B. So let's say I'm collecting data on students that like apples and students that like bananas. In the middle would represent students that like apples and bananas. In the apple circle, but not in the intersection, would be apples only. And over here, this would be people who like bananas only. So what do you think would be represented by the space outside the in the box, but outside the circle? Students that like neither apples nor bananas. They don't like either one. So that's what we're going to be doing, is looking at how can we use a Venn diagram to illustrate some data and then use it to find a probability. So that was just a quick rundown on that. But when I ask for the probability of A, I need you to understand that that means I'm asking you how many are in circle A total in circle A over the total number that are represented in the entire Venn diagram. Your total, by the way, will always go out here outside of the Venn diagram. So probability of A would be all of A. So if you've got a number here and a number here, you would add them up and then divide by your total. For the probability of B, you can probably guess that it's similar. It's all the data represented here in B, including here in the intersection, divided by total. So we'll put equal to B over total. And of course, by B, I mean the number of numbers you see. Okay? Next, for these two below, this is new terminology as well. We've talked about the probability of an event A or B here, but now we've got a new symbol to introduce. This symbol, it looks like an upside down U, so I'm going to say it looks kind of like an N, but without the tail. So understanding that, what I mean by that is, like, if I drew a lowercase n, we'd have a tail and then an n. So it looks like that, but without that little tail. So, but what I want you to think is, because it kind of looks like an N, it represents the intersection. The intersection. So if it's upside down like an N, that looks like that's the intersection. So that would be here in the center. So if I'm asking you for the probability of the intersection, I'm asking you for the middle. So I'm going to call that both A and B, so both, divided by total. Again, where the total number comes from the number right outside, meaning all the values represented in the Venn diagram. So if the upside down looks like an N here for intersection, this looks like a U. So this symbol here is like a lowercase u, but without the stem. So it's like taking that stem off, okay, for both of those. So this symbol means union. So I want you to think about if you've been to a family reunion, or you've been to a marriage, as in the union of two people. The union is the joining together. So if I'm asking for the probability of A union B, then it's going to be the union of these two circles. So that means everything in only A, and here, and here. So in other words, all the circle stuff, the sum of everything in the circle. So again, we're just going to combine everything in here for A and B. So the probability of A union B is the sum of the circles. So I'll put sum of circles divided by total. The other thing I want you to be familiar with is we often say instead of A union B, this is the same thing as saying A or B. So think about it like this. Say you're going to a wedding, and when you go to the wedding, sometimes when you go in, they say, "Are you with the bride or the groom?" Well, you could be with the bride, or you could be with the groom, or you could be with both. Say you're friends, right? So you might have family of the bride, family of the groom, and then friends of both. So if they say, are you with the bride or groom? You could say, yes, I am. It doesn't matter if you're here or here or here. Okay? You're all with the bride or groom. If they say bride and groom, of course, that would be right here. So this union means or, so I want you to think union equals or. But intersection would be and. So this would be A and B. So you often will see probability of A and B. So in other words, the intersection means and. Okay, very important point there. So it doesn't matter whether you see it in symbols or if you see the words. So say if you're reading a problem and instead of using the probability symbols, they're using words. If they say, what is the probability that a student likes apples and bananas, that would be these students here. If they would say, hey, students who like apples or bananas, y'all come here. Then come here and get a snack. Well, these people would come get a snack. These people would come get a snack. Wouldn't these people come get a snack if you said, hey, students who like apples or bananas, come over here and get a snack? They would come too, so they get included. Okay? So think about union being way more inclusive, like a family reunion or a wedding, a lot, bunch of people getting together, a union. Okay? All right, so now we're going to apply that by looking at some questions with Venn diagrams here. So I've got a Venn diagram started for you, and we can look in here and see that in the circle it says dog and cat. So that means that this circle represents dog. So everybody in this circle maybe has a dog, and everybody in this circle has a cat. So let's look at what it says. It says 30 students are asked if they have a dog or cat. So that is a total. And where do we put total? Out here. So draw a line and put 30. So by the way, whether you could print this or not, you need to write all of this in your notebooks. Every bit. Draw the circles, draw the rectangles, circles. If you've got highlighters or something, that's even better. But you're going to basically copy every bit of this in your notebook today, and then tomorrow you'll be doing practice. So make sure you're writing it all down, whether you can print it or you just need to write it in your notebook. So 30 are asked if they have a cat or dog. That's going to go on the outside. 21 have a dog. Do not let that fool you. Do you see here where it says dog 8? This means dog only. Okay? 21 have a dog. I'm going to come here, and I usually come up here and do it. 21 have a dog. Put that outside. That's to help you understand that just because they say 21 have a dog, it does not mean you automatically put it in the circle. It means that 21 is the sum of both the dog only and dog and cat. Okay? So 21 have a dog. They also say that 16 have a cat. Do not go put the 16 over here. Don't put it here. 16 have a cat. That means that these two numbers together add up to 16. Okay? And same over here. These two numbers over here will add up to dog, which was 21. Okay? So be cautious about that. So now they also then say that 8 have a dog but not a cat. So that's what that 8 represented. 8 have a dog but they don't have a cat. And then you have to make sense of the rest. Okay. So that means I'm going to take this information, the fact that we have 21 that have a dog, and we know that 8 have a dog only, and we are going to subtract. So in other words, 8 plus what number will give us 21? So that means I'm going to do 21 minus 8, and that gives me 13. So that means the sum of all of this here in my circle, I'm going to highlight this in pink. All of this adds up to 21, the 8 plus the 13. It's a simple subtraction. And then, let's switch colors here. That means that the two numbers here for both cat and dog and cat have to add up to 16. Well, how are we going to get that? We're going to take the total 16 and subtract out the 13, and that leaves us with 3. So let's see if this makes sense. 8 plus 13 is 21 people having a dog. 13 plus 3 means that 16 people have a cat. So when you read these statements, the biggest mistake students make is they automatically go, oh, 21 have a dog. 21. Wrong. 21 is the total for the dog circle. Okay? Now, you notice that I've got a dotted line over here, and that's because we may have students that do not have a dog or cat. I'm sure if I asked a lot of y'all right now, do you have a dog or cat? Some of you are going to say neither one. So how do we determine how many have neither? So that means these three numbers, if I find the sum and take it away from the total number of students surveyed, that would leave me with the students that have neither. So in other words, my neither is going to be equal to 30, my total, subtract the ones that I do know, 8, 13, and 3. Be careful, don't subtract the 21 and 16. So we're going to add up the three numbers in the circle. So 8 plus 13 plus 3 is 24. So that means 24 have either one. They have a dog or a cat. So 30 minus the 24 leaves us with 6. Okay? So again, your neither is going to be your total. Subtract whatever the numbers are in the circles. Okay, your total minus whatever numbers are in the circles. All right, so let's see if it makes sense. If it makes sense, if all these numbers are done correctly, watch what will happen. They will all add up to 30. So let's do that. That's a great way to check. 8 plus 13 plus 3 plus my 6 down here should always add up to my 30. Okay, then I can ask you other questions like, what's the probability of a student having a dog? 21 out of 30, because there's 21 students that have a dog. So there's different things we can ask, but this was just about making sure you understand how to fill one in. All right, pause if you need to. I'm going to be flipping a page. All right, next in your notebooks, remember to pause the video at any time if you need to. But for number 2, it says 50 students were asked in a survey whether they use texts or social media. So 50 students, that's your total. Where does your total go? Here on the outside. Okay, so next come down here to the bullets to find the information to go in our Venn diagram. It next says that 20 students said they use only texts. Careful, that is only using texts. So that's not a total for text, that's only text. So we are gonna put the 20 here. You always have to read it carefully. If they use the word only, that's how you know it's text only. Okay? So just to kind of help you out, I'm gonna shade a little bit purple. So this here, this area here means only texts. Okay, just this outside. Now it says 8 students said they only use social media. So social media only, that would be these guys. So only social media, that's 8. Next, 17 students said they use both. Well, that would be they use text and, there's that word again, and for intersection. They use text and social media. So that's going to be in the intersection here. So that would be 17 students. So we put this information on the Venn diagram, but notice I should have a total of numbers that add up to 50. So does it? Does 20 plus 17 plus 8 add up to 50? No, because what? Some students don't use text or social media. Okay? So remember to find this, the students that use neither. Again, that's total minus all the numbers in the circles. Your total is here. So I'm going to do 50 minus, when I added up the 20, 17, and 8, I just did that in my calculator. 20 and 17 and 8 gave me 45. So if I subtract out the 45, I have 5 out here. So now all 4 numbers will add up to 50. Please, please, please make sure when you do your Venn diagrams you are checking to make sure they equal the total. So we have put this information in a Venn diagram. Now we are asked how many of the students in the survey do not use text or social media, and that was 5. That's what I just showed you. This was the work for that. Next, one of the students is chosen at random. What is the probability that they use texts? Well, notice it does not say text only. It just says how many text. So do these students text? Yes. Do these students text? Yes. So that means I need to add these two together. So that's going to be 20 plus 17 divided by your total, which is 50, or 37 out of 50. So the probability that one of the 50 students texts is 37 out of 50. Now, we're leaving the probabilities as numbers, but remember the day before yesterday, we did understanding that probabilities can be interpreted as percents, right? So I would just like you to understand that, yes, we are asking for a fraction, but it is equal to a value of 0.74. Recall that probability is always a value between 0 and 1. So think about this. Is a student unlikely, equally likely, or more likely to use text? Remember, if it's between 0.50 and 1, then that's like 74%, so they are more likely, right? So 37 out of 50 equates to a probability of 0.74 as a decimal, which is 74%. So they are more likely to text than not text. So remember, because we did stuff where it was like more likely, less likely, that kind of thing the other day. So if I ask for probability, this is the number I want, but understand if you were taking like the ACT test or say it was a multiple choice test and they chose to use decimals, that we should understand that as a fraction, it can be converted to a decimal and a percent. Okay? But on these, we're just going to ask for at least the fraction. Okay? All right. And next, for number 3, we are given a set of numbers, and then we have to draw and fill in a diagram. And then look, we've got to answer some questions down here about it. So we are first going to draw a box just like we do the other ones. So I'm going to use a pencil here. Do I have a sharpened pencil? Yep. All right. So I'm going to draw a rectangle, make it a good size. And I'm going to, on the left side, draw a circle. And then I'm going to draw another one to overlap. So what I normally do is kind of come over here, think about if this was a clock, I come over here at about 2 o'clock, like, you know what I mean, like 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, maybe 1:30ish, like halfway between. And I just come down here and make another circle. Ooh, that's kind of, don't have to be perfect. Clearly I'm not. So we've got 2 circles that overlap. And we are given numbers that where it says that S are square numbers. So by that we mean perfect squares. Well, that requires us to remember what those are, right? So remember that means 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So I just want to remind you of what perfect squares are. And even numbers are actually numbers that are evenly divisible by 2. And believe it or not, 0 is an even number. So 0, 2, 4, 6, 8, etc. So just a quick recap of what squares and even numbers are. So let's come over here and put an S for squares and E for even. And now if you like, you can pause the video and see if you can fill in these numbers appropriately in the space. So in other words, 1, is it a square? Yes. Is it even? No, but it is a square, so just put the number 1 in there. And once I'm done, I'm just going to kind of lightly mark it out. Then if we think about 2, is 2 a perfect square? No, but is it even? Yes. So a 2 would just go over here in the even circle. So if we think about 3, is 3 a perfect square? No. Is 3 even? No. So I can't put it in the circles here, so I'm just going to come down here and in the box list that number. Okay? So if you want to hit pause now and see if you can fill them all in the appropriate space, feel free to go ahead and do that. So I'll just continue here. That 4, is it a perfect square? Yes. Is 4 even? Yes. So it's both. It goes in the center. 5, not a perfect square, not even. In fact, it's, if you notice, perfect squares can be even and odd numbers, but they're not all evens or all odds. But 5 is not a perfect square, so I'm going to come down here and list it down here at the bottom. Number 6 is a even number. 7 is neither even nor a perfect square. So I'm going to put that down here at the bottom. 8 is even but not a perfect square. 9 is odd, but it is a perfect square. 10 is an even number but not a perfect square. 11 is odd and it's not a perfect square. And 12 is even but not a perfect square. So one of the things you want to do is either cross stuff out when you put it in, or maybe recognize that you can count the numbers here and make sure they match the number in the set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers here. So in other words, I have 12 numbers total. So I'm going to put that on the outside for 12 numbers. Okay? So now that we have that, let's answer some probability questions. So on the first one, they're simply asking us, what is the probability of being a perfect square? Well, all these numbers are perfect squares. How many of them are there? There are 1, 2, 3 numbers from this set of numbers that are perfect squares. So a probability of one of these numbers being a perfect square is 3 out of the total 12. There are 3 perfect square numbers out of 12. Next, we got to go back and remember what this means. It looks like what letter? It looks like an N for intersection. So think about it. If you're riding down the street, driving in a car, isn't this the intersection? It's where the 2 roads meet, right? So it's where the 2 circles meet. So it's going to be here, the intersection. What is the probability that a number is a perfect square and even? And how many of those were there? Only 1. So the probability is going to be 1 out of 12, our total. Next, this is a union. Remember, they might say, are you with the bride or groom at that wedding, which is a union? or groom and groom, or bride and bride. So for union here, it's going to be all of these, right? So I'm going to highlight this in yellow. So if you don't remember this, then you should go back to the first part of the notes where we did this. So union was all of these numbers, okay? So it's going to be everything in here and in here. So how many values are there? What's the probability that one of those numbers is in here? Oh, it looks kind of orange now. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of the 12 numbers are perfect squares or even. So I'm going to put square, that was a cube, believe it or not. Square or even. And this would be square and even. So the 4 is the only number that is a perfect square and even. Okay? All right, pause if you need to. I'm going to go ahead and move on. This is the last set here. So I am giving you a Venn diagram, and it is similar to the last one, except it's not about perfect squares or even or odd. It's just a random set of numbers. And the first thing I'm doing is asking you to write down the numbers that are in set A intersection B. So remember, this is intersection, or in other words, and. Okay? So, and, I'll highlight like I did before. What colors did I do before? I think I did, or was the purple. So A and B would be here. And there's how many of those? There's 2 of them. So I'm just going to write down the numbers. So I'm just going to list 12 and 18. So I'm just saying, do you understand what these symbols represent? Next, I want you to write down the numbers that are in set A union B, or B. So that means, again, all the numbers that are in the circles. Okay? So I'm going to just simply list them, and I'm just going to not put them in numerical order, but you're welcome to. I'm going to list them from left to right. So 15, 12, 18, 14, 10, and 16. So again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have all 6 numbers. Now I want you to write down the numbers that are not in A or B. Not in A or B. This is different, new concept. Well, that's these numbers. So the numbers not in the set are 11, 13, 17, and 19. So notice down here we've got 3 points here. We call the set of numbers not included in a set the complement. So these pink numbers here are known as the complement. Now that's different from like someone saying, man, you smell nice. That's a compliment, right? But the complement in a set of numbers are all outcomes that are not in the event. Remember, the event is whatever's in the circle. So the event here would be A or B. So it's what's not in the set, not in the event, okay? Altogether, by the way, the event, meaning what's in the circles, and the complement, what's not in the circles, make up all possible outcomes, okay? So let's take a look at this here. It says so I've got a Venn diagram with 2 overlapping circles, and now it's shaded everything outside the circles, but still within the Venn diagram. So I'm going to just take a highlighter and go over that darker. You can take your pencil and just shade in the box, but not in the circles. But remember, whatever is in the circle is the union. But I want you to notice a symbol. Do you see this symbol? Look right here outside of the A or B. It looks like a little apostrophe. You might have seen it before with maybe prime notation. But this symbol in probability, if you see this symbol here, it means the complement of A and B. of A or B. The complement of A or B. In other words, everything outside of the circles. Okay, so just in layman's terms, everything outside the circles. That's what that means. The complement is everything outside the circles. In this case, okay, now I could say the complement of A, and it would be everything except A. I could say, so there, we can find complements of multiple things, but I just wanted to share with you that that symbol there means it's the complement, which means everything outside of whatever this is. Okay, so just to kind of drive that point home, I'm just going to use my space over here to the left, and I'm just going to do a circle, and we're going to have a set that's only C. So no overlapping circles. If I call this C, and I say, what is the complement of C, then it would be everything out here, everything outside of C. Does that make sense? Just to further drive it home, if I did have two circles that overlapped, and I called this, let's see, is your favorite color about Christmas time? So red or green. Students whose favorite color is red or green or both. If I say, what is the complement of G, it would be everything except what's in circle G. So it would be all of this is not in circle G, but all of this is not in circle G either. So it would be everything except G. Does that make sense? Think about it that way. So the complement of this union would be everything outside the circles. The complement of G would be everything except G. And the complement of C would be everything except C. All right. Pause it if needed. Feel free, guys, if there's any one concept that was kind of confusing, just go back and rewatch it. Listen to it again after you've written it in. Just go back and re-listen to the notes or a particular section. So last one here, and then we're finished, and then that's all you had to do today was submit a copy of your notes, and then tomorrow all you'll do is use these notes to help you answer questions, and the handout will be very similar to these types of questions. So let's see what we've got here. We can see that our job is to construct a Venn diagram, and we're going to answer a probability question about a complement. So let's see what we've got. So last year there were 36 pupils in a class. Of these pupils, 20 studied French, 9 studied German, and 3 studied French and German. So that tells me in my Venn diagram that I'm going to be using F and G to represent students taking French. And remember about 1:30, 2 o'clock up here, students taking German. So I'm going to do F and G. All right. So next, we got to build this correctly. So it says 20 studied French. Does it say French only? No. It says 20 studied French. So that's our French total. 9 students studied German. Does it say German only? No. So that means I have to put 9 on the outside as a reference point. But it does say that 3 studied both French and German. So and, again, that word and means the intersection. So I can put 3 in the middle. So I'm going to use this fact that these two numbers add up to 20, but I have 3 to do 20. I'll just come over here and say 20 minus 3, which would give us 17. Remember that 17 plus 3, so these students took French only, and these students took both. But if I ask these 3, do you take French? They're going to say yeah. So they count. So 17 plus 3 is 20. And then for German, if there's 9, but 3 also take French, then all I do again here is do 9 minus 3 and get 6. So does that mean that all students are taking a foreign language? Well, let's see. There are 36 pupils in the class, so let's put that out here as our total. And, are they all taking French or German? 17 plus 3 plus 6 is 26. But there's 36 students in the class, so what does that tell us? It tells us that 10 students take neither one. That there's 10 students that are going to say, no, I don't take French or German. Okay? So this is your neither. And again, this is your total. So now do all these add up? Yes. 17 plus 3 is 20, plus 6 is 26. 26 plus 10 makes 36. So that should make sense. We should notice what would happen. If we added the 20 plus 9 and this number, it just wouldn't make sense because you can't put 20 here and 3 here. If you were to put 20 here, then 23 would be taking French. But it says that only 20 take French. So that would not make sense. Be careful and read it carefully. So now notice it's saying, you see this apostrophe up here. This is the complement again. So this is the complement of French. What's that symbol mean? Union, meaning or, German. Well, that means you have to know what F or G is. If I ask these 17 students, do you take French or German? They're going to say, yeah, I take French. If you ask these 3 students, do you take French or German? They're going to say, yeah, actually, I take both. These 6, if I ask these 6 students, do you take French or German? They're going to say, yes, I take German. So all these 3 are, remember the or. So remember, union, join these 2 together. So the students not that are, so if we consider that, the complement is those not in the circle. So remember up here, we said that this is A or B. So the complement would be everything outside the circles. So again, this complement, I'm going to highlight this in yellow, is going to be anything, any number that is not in the circle. Well, how many are not in the circle? In the circles? 10. So remember it's probability, so it's a ratio. 10 out of our total, which is 36. Something else you can think of is if the probability of F and G is 26 out of 36, then the probability of the complement should be the difference. So 36 minus 26 was 10. Does that make sense? I hope so. All right, so make sure you've got all this down in your notes, upload them into Canvas, and then tomorrow you will practice. Otherwise, today, just make sure that you are finishing any assignment that you have not completed yet this week. All right, have a good day.